Welcome to all. This is Tanu Gupta, Assistant Professor in IT Department at Akgec Engineering College. Today we are discussing a very important topic in data analytics, that is our Flajolet-Martin algorithm. So first we understand what is the use of Flajolet-Martin algorithm and where it is used. Flajolet-Martin algorithm, it is used to count the distinct element in a data stream. If we have a string like 0, 1, 2, 0, 1, 0, 1, 2, 3, 4 and so on, in which we have to count the distinct element, the number of different element. It is used to count the different number of element in a string. So first we discuss about the algorithm, then we discuss the example to understand all the concept. So Flajolet-Martin algorithm. Yes, as we already told you, the Flajolet-Martin algorithm, also known as a FM algorithm, it is used to count or used to approximate the number of unique element in a data stream or database in one pass. Okay, the highlight of this algorithm is that it is used less memory space while executing. So this one is a pseudocode for the stepwise solution of the FM algorithm. So first we have to select a hash function. In the Flajolet-Martin algorithm, we have given a number of a string, a data stream, and a hash function. Selecting a hash function h, so each element in the set is mapped to a string at least log 2 of n bits. First of all, in the Flajolet-Martin algorithm, or in this numerical, we are already given a string and a hash function. Selecting a hash function, then for each element of the string, we have to hash to for all the element to the hash function. For each element x, in the data stream, we map the hash function. After that, find r of x, the length of trailing 0. Then after that, we convert it into a binary string, and after that, the length of the trailing 0 according to that hash function. Then the value of r is equal to max r of x. Then we calculate what is the value of maximum number of trailing 0, that we denoted by r. So the number of distinct element according to this is 2 ki power r. R is a number of trailing 0, maximum value of the trailing 0, that is r. And number of distinct element we represented in this by r. R is equal to 2 ki power r. So by this formula, we can calculate the distinct number of element in the Flajolet-Martin algorithm. So to better understand this algorithm, let us take a simple example, or just discuss before that we will discuss some few points. Like FM algorithm is very sensitive to the hash function parameter. If you choose a wrong hash parameter for a given stream, so the answer will fluctuate and answer will not predict an accurate value. So the hash function used in the above code is of the form ax plus b mod c. So hash function in the Flajolet-Martin algorithm will be in the form ax plus b mod c, in which x is a various element in the stream, a, b, c are the hash function parameters. Okay. So it is important to observe that stream and then assign proper value of the ABC, so that our algorithm will get a accurate result. Now, consider to an example for the Flajolet-Martin algorithm. For example, for a given input stream, we have a stream 1, 3, 2, 1, 2, 3, 4, 3, 1, 2, 3, 1. Given that there is a input stream is of the form, and we have a hash function which is on the form ax plus b mod c. X is various element in the stream, where the value of a is 6, b is equal to 1 and c is equal to 5. These are the hash function parameters a, b, c. So first we have to calculate, or we calculate the hash function according to that. Okay. So how we calculate this, the hash function? What is the hash function? H of x. H of x is equal to 6x plus 1 mod 5. This is a hash function as in the given question. So what is the first element in the given input stream? 1. So we will put the value of x is equal to 1 in this hash function. 6 cross 1 plus 1 mod 5. 6 cross 1, 6 plus 1, 7. 7 mod 5, that is equal to 2. It is equal to 2. Similarly, we calculate the hash function for the various element in the stream. For the second element, that is h is equal to 3. The value of x is now 3 because the second element is 3. Now we put the value of x in that. 6 cross 3, 6 cross 3 plus 1 mod 5. 6 cross 3, that is 18. 18 plus 1, 19 mod 5. 19 mod 5 is equal to 4. So, like this procedure, we calculate the hash value for all the element in the stream. Like h of 2 is equal to 3, h of 1 is 2, and for the various element. So, this is our first step in the Flajolet-Martin algorithm, in which we have to calculate the hash function for all the value for all the element in the given input stream. Now, come to the second step. In the second step, we convert this value into a binary format. Okay, so the value of 2 is 210 according to the 8421 format. 010, 4 is 100, 3 is 011, 2 is 010, and so on. The second step is to convert this value into a binary format, convert the decimal number into a binary number system. So, by the conversion procedure, we convert the decimal number system into binary number system. So, these are the value in the second step. Now, comes to the third step. The third step is to count the number of trailing 0 for each hash function. So, in this step, we have to count the number of trailing 0 for each of the hash value. Now, for x is equal to 1, this is a hash value. This is we already convert in the third step into this binary number. Now we have to count the number of trailing 0. So how to count the number of trailing 0? Start from the right hand side and count the number of 0 from right and stop when there is 1 is encountered. Okay, so start from the right, count the number of 0, that is 1. 0 is 1, and stop when the 1 is encountered. So, number of trailing 0 is 1. 4, 1, 0, 0. In this, the number of trailing 0, start from the right, count 1, 2. And where we stop? When the 1 is encountered in the string. So, 1 and 2, there are 2 trailing 0 in the second hash function. Start from the right, there is no 0 in this and 1 is encountered. So, here 0 will be the number of trailing 0 is in that hash function. Now, as we discussed in above, start from the right, count the number of 0, that is 1, and stop when the 1 is encountered. So, the number of trailing 0 is 1, as in this case 0, 2, and in this case 0, 0, 0. There is no 1 in this string. So, the number of trailing 0 is 0 because this string goes to infinite and we cannot decide where we stop. So, the value of this string is 0. So, by this procedure, we calculate the number of trailing 0 for each of the binary number for each hash value that we calculated in the previous step. Now, the third step. As in the next step, we will check what is the maximum value of trailing 0. 1, 2, 0, 0, 2, 1. So what will be the maximum value in these value 1, 2 or 0? That is 2. So the value of R is 2. So the value of R is 2. So the distinct, how we calculate the number of distinct element in the string? Distinct value R is equal to 2 ki power R by this formula. R is equal to 2 ki power 2, that is 4. Hence, there are 4 distinct elements as 1, 3, 2, 4 in this, the given input string. So this is how we calculate a number of distinct elements for a given input stream by using the Flajolet-Martin algorithm. I hope you understand this algorithm. Now, we cover the next topic that is also a important topic in data analytics, that is a Bloom filter. So first we understand what is Bloom filter and where it is used. A Bloom filter is a probabilistic data structure which is used to test whether an element is a member of a set or not. Okay, what is Bloom filter? Bloom filter is used to test whether an element is a member of a set or not, or we can say it is possibly in a set or definitely not in the set. There are two results that a Bloom filter will produce, that is, it might be present and surely not present. Bloom filter input hash function. So Bloom filter is used to test whether an element is possibly in a set or definitely not in the set. It is a space efficient and very fast, but it is a trade-off. It can return false positive, through it will never return a false negative. Might be present means return false positive, and surely not present, never return false negative. What is false positive and false negative? Let us understand what the term is about. For example, checking a availability of username. When you sign up for an Gmail account or any other website, you have to sign in or register for an account. You entered a username. For example, with your name, you want to register yourself. So you entered a username like your name. Then you press the button check availability and suggest to choose another name or another name because this is availability in that database. So you put on just your birthday date or a son and so on, and further check the availability. Okay, so can you imagine that how the fast check availability use this function to assure you that this is available, this is not available, choose another string and so on. So here a concept of Bloom filter arises. Bloom filter, we use a Bloom filter to generate such a result very fast. But advantage of Bloom filter is that it will assure you it might be present. But our trade-off is that it can be a return false positive result, but it never return a false negative. What I want to say that if you are registering in a website, or you're signing up in such a website, or you register, when your when a username is present, already present, then a Bloom filter will never generate a false negative result. Then it cannot state that then this username is not present. It always assured you that it present and choose another name. Okay. And what is a return false positive? If a username, if maybe a username is present and you entered that name, it may be resulted in that it is present, choose another name. It can be possible, but it can never be return a false negative result. False negative result means that if a username is already present and a Bloom filter never state that that a username is not present in the database and register. Okay, so false positive means it might tell the username is already taken, but it's not. And a Bloom filter never generate a false negative result, telling that a username does not exist when it is actually exist. So this is the main concept of Bloom filter, where it is used, as we discussed, in checking the availability of username. And it may be result in two ways. Might be present, it can be name is might be present, and surely not present. There are only two answers we have got from the Bloom filter. It might be present and surely not present. It might be present, there may be positive and negative point, but in surely not present, it assure you that this username or this element is surely not present in that stream and is on the database. Okay, now these are the two operations that we that support the Bloom filter. Insert operation to insert an element in the Bloom filter. Yes, we insert an element into the Bloom filter, and a second one is a lookup operation. Lookup operation is used to check whether an element is already present in the Bloom filter or not. To check whether an element is an present on Bloom filter or not, we are using our lookup operation, and to insert an element into the Bloom filter, we use an operation. And we cannot delete an element into the Bloom filter. And it can be noted that we insert or we check element into the Bloom filter, but we cannot delete an element into the Bloom filter. Deleting element on the Bloom filter is not possible, because if you are going to delete a single element by clearing its bit, it might generate a key hash function, and it turn to be a deletion of other few elements. So the deletion in the Bloom filter is not possible. There are only two operations that could be possible in the Bloom filter: insert operation and a lookup operation. This is a simple working of Bloom filter, in which empty Bloom filter is a bit array of m bit, all set to 0. First, a bit of m array, all bits set to 0, and then we need a k number of hash function. In the Bloom filter, we are given m bits. First, initially, we put all the m bits in the 0. Okay, we need a key hash function, a number of hash function 2, 3, 4, a number of hash function given, and then hash it with the value. Okay, then we apply a filtering or insert a lookup operation into that. This is a simple algorithm how the Bloom filter is work. That is, understand what are the various points in that. Initialize a bit array of size m. As we discuss, m size, for example, 5, 0, 1, 2, 3, 4. Because this is an array, so we starting at index at 0. Initially, all the bits in array are set to 0. Okay, next, choose k different hash function. each of which map element to one of the m position to the bit array. There are given a k hash function 2, 3 and 4. We map all and we positions according to the hash value on that. To add any there are two operations to add an element, that is a insert operation, hash it with the each k function. So for this procedure, when we have to insert a new element, for example element 2, then hash it with all function, set the bit all k position to 1, and when the hash it with, then there is some value, and so on that location we put 1, set all the bits is equal to 1. And to check whether an element is in the set or not, hash it with all k function. If all the bits are 1, that it might be present, and if any of the bit is 0, that we hash it with other hash function, it definitely not in the set. So there can be a two answer. It might be present when all the bits are 1, we can say that it might be in the set. If any of the bit is 0, we surely said that definitely not present in that set. Okay, so this is a overall working of a Bloom filter, and it is also used to check whether an element is present or not. So we follow this step to insert an element or to check whether an element is in the set or not. So this is a approach that we or a system follow to check an element in the set or not, or check an element in the database or not, like as we discussed in the check availability buttons in the like of a username. So Bloom filter uses this approach to check whether an element is present or not. So I hope you clear all the points that we discussed in the Bloom filter and the Flajolet Martin algorithm. Good day. Thank you.